Record. All right, so this is AP Calculus AB. We're doing self-check 11.3. This is the key. This is a calculator-enabled self-check. And my internet is probably not the best right now, so hopefully it's not too much of a lag. Here's our quadrant R. We're trying to find that area of R. So I say that that area is going to be equal to, obviously it's the integral between the x coordinates 0 and 2.
Okay.
And that's going to be top minus bottom. So top is 6 minus the bottom. That's going to be 4 natural log of infancies 3 minus
Billy
x.
was making me excited to probably do that.
All right, I should probably mute you guys too. Sorry, Arrow. All right, you've been muted. This is all times the quantity of d of x. Okay, and then I just punch this into my calculator, and I did these in ahead of time. So here's the first line. It's 6.817 rounding. So this is equal to 6.817, and final answer, box it. If there are any questions, go ahead and unmute yourselves and ask questions. But again, the hint is always for area, it's top minus bottom. For area. Let me write our formulas as well. Okay, so part B, find the volume. Go away. All right, so find the volume. When I'm rotating around the horizontal line, y equals 8. So here's y is equal to 6. Y is equal to 8 is above that. So y is equal to 8 is like somewhere up here, which is going to make things reverse, right? So now my outer function is actually going to be this curvy natural log function. So my formula generally for volume looks like this. Volume is equal to, whenever you have the word revolve, immediately put pi, because we're going to have circle cross sections, and then the integral from start to end, or start to end of outer squared minus inner squared. Oh, I guess it's outer minus k quantity squared minus inner minus k quantity squared. So that's the general integral. So here's ours. We're going to do pi integral from, again, 0 to 2, because that's not going to change the entire problem. And it's going to be, so my outer now is the natural log function, as I said before. So it's going to be 4 natural log of 3 minus x. And then that's going to be minus 8, because 8 is our k value up here. That quantity is going to be squared, and then we're going to minus our inner, so it's going to be 6 minus 8 quantity squared, and then all of this thing dx. All of that stuff dx. Okay, and then you just type it into your calculator, and I already did that up here. That's what it looks like, and I got 168.17, I guess 1.80, right? So I'll say this is equal to 168.180. And I don't know, I kind of like the idea of entering it into the calculator in advance. That way it saves time. But if you want to show, or if you want me to show you how to do this, I know that most of you have like the newer calculators anyway. Maybe this isn't that valuable.
Wait, no. So I got the same thing, except for I got it negative. What do you think the problem was?
You did inner minus outer. You switched these two values.
But I would still get the same answer. It wouldn't matter. I don't know. I feel like that would be different.
So you have to think about it maybe in terms of the geometry of what's happening. We're saying take a big shape minus a small shape. You're saying take a small shape minus a big shape. So it's the same area, but
okay.
Yeah, the difference is still the same, exactly. And that's super important to know too, because when we're doing these calculations, you can just be like, oh, we'll just make it positive, and then you'll get the, I think you'll get the full points. Maybe I would say, just for a blanket statement, go back and erase your work, or just write an arrow or a Claire to switch these two and say, hey, I got these backwards, and here's the correct positive answer. Your answer should always be positive for volume, and for area between two curves, you're also will have always a positive area. The only time that you'll have a negative area is when I'm specifically looking at one function underneath the x-axis. If I have two functions, it doesn't matter where those two functions are, I'll always have positive area. All right, and then finally for part C.
If you don't write the dx, will you get points taken off if we end up doing the AP test?
You might, because sometimes they say you have to have the integrand correct, and dx is part of the integrand, so you might get points taken off. Sometimes they say you just need to have these two functions, or sometimes they say you need to have all of like the equation, or sometimes did you remember the pi? It really depends on the scoring key, but as a general statement, have the d of x. You might get points taken off.
Okay.
Yeah, good question. Okay, and then I have square cross sections, and they're perpendicular to the x-axis, which means I'll have a d of x, which is the way that we've been doing it the entire time. And I've been giving you guys warning lights, like we're gonna have on the pretest and on the test at least one function where I say perpendicular to the y-axis, which means every function needs to be changed. So if I had something like y is equal to 3 minus x, you just change it and say, okay, subtract 3, so y minus 3 is equal to negative x, and then multiply everything by -1, negative y plus 3 is equal to x. Now I have a function that's written in terms of x instead of in terms of y. Now this function is ready to go around the y-axis. So just be warned, that is approaching us in the near future, but this one is a nice and easy problem. Just make sure you have the basics down. All right, so let's go ahead and do this. The general formula for volume of square cross sections looks like this. It's the integral from the start to the end of your, I guess it's just top minus bottom quantity squared. That's it. So what do we have? We have the integral from 0 to 2 still. Oh, also the bounds change if it's switched to the y-axis. It changes the bounds from the y coordinates instead of the x coordinates. But our x coordinates are still 0 and 2 for this one. So integral from 0 to 2. Okay, top was 6 minus bottom was that 4 natural log 1, 4 natural log of, it was 3 minus x. And then this entire quantity squared. Because again, if you want to be thinking about it visually or geometrically, you have a square where this height is obviously the top minus the bottom. So that's why we did top minus bottom. But then I need to multiply that by this other height that's coming out of the paper, and that's the same length. And then this all of dx. Okay, so I did that on my calculator, but I didn't hit enter because it would have pushed off the previous line. And I got 26.266 repeating, so 26.267 if I'm running. So this is equal to 26.267. And I should be boxing these final answers, even though my work is pretty straightforward. Sometimes you are writing everywhere, and then it's hard to see on the AP grader side. Let's do this. All right, so we are on self-check 11.4 now, and it's basically the same type of things, except now I have a harder function. I have like 2 curvy functions instead of just y equals 6, right? So f of x, this is my top function. My bottom function is that g of x, and we know their intersection is 0 and 1, so we don't even need to find any intersection. Let's go ahead and find the area. Again, the formula for area that you should have memorized by now is it's the integral from the start to the end of the top minus the bottom. So our integral is going to be the integral between 0 and 1 of this. I'm just going to be lazy here. I'm going to say f of x minus g of x. You don't have to write out the entire formula again. You just have to show your work. So this is me showing my work. F of x minus g of x quantity d of x. Okay, and then what is that thing? Pull up my calculator, and I already did it up here, and I got 1.133. So come back up here and say this is 1.133. Final answer, and box it. Questions.
Did anyone get 1.833?
I got 1.833.
1.8.
Okay, that's what I got too.
Can you pull up your y equals? Did you type them in correctly?
Oh, no, I didn't see that square root there.
No, I didn't either.
Okay, that's
interesting that 2 people got the. That's so rare that happens. Yeah. Okay. So, just reading the question. Yeah, that's hard. Sometimes.
Every time. Okay.
Part B. Yeah, I'm glad that it was caught. Okay. Find the volume when I am doing. Okay, I'm revolving every single time I see revolve or rotate. I'm gonna add a pi. So our general formula for volume, before I actually plug everything in, should have a pi. It's an integral from your start to the change, and it's going to be around y equals 2. So it's going to be outer minus k quantity squared minus the inner minus k quantity squared, and then all of that stuff dx. And I'm not going to put that for my formula, but here we go. Okay, my integral is going to be pi, then the integral, again from 0 to 1. And what is my outer function? It's, well, I guess I have to draw y equals 2 to find where that is. So if I come up here, well, there's 1, so 2 is like up here somewhere. That means my outer function is g of x, not f of x. If I put g of x, I will get or if I do f of x first, I'll get a negative answer because that's the smaller one. This radius is smaller than that radius right there when I'm doing my cross section. All right, so here we go. I just said it's going to be g of x. Again, I'm not going to write out all of g of x. I'm just going to write g of x and then minus, it's 2. Quantity squared minus, and then it's going to be f of x minus 2, that quantity squared, and then all of this stuff d of x, all of that d of x. And again, plug it in your calculator. Running out of time, go away, I know. So second mode, I already did that as well. And remember, I just typed in my pi already as well. So I don't have to re-multiply by pi. And I got 16.179. So this is equal to 16.179. And now that you guys have the correct equation, I imagine that you'll probably be getting the correct answer if you had to redo this. Any questions on part B? And we're moving on to part C. All right, so I have each section is perpendicular to the x-axis, so dx still, and it's a square, so square cross-section. So the general volume when I'm doing square cross-sections, again, is the integral of your top minus bottom, that quantity squared. So here we go.
You get the pi.
Say again?
Oh, never mind.
Oh yeah, so yeah, no pi because it's not rotating. Yeah, and that was the most common error from last year. We'll see what the most common error is for this year, and I can have 2 common errors I can carry over to next year, right? And then this one's going to be, the top is f of x still. So f of x minus g of x, and this quantity is going to be squared. I need to have my integral in here too. That quantity squared d of x, and add the integral from 0 to 1. And I think I've typed it in all correctly. So integral of those two and then squared. Okay, hit enter. And I should get 1.493 according to my answer key from last year. Yeah, 1.493, there it is. 1.493, final answer, and box it.